Basically, in fabric geometry, we discussed about the shape and the structure of the different fabric types. In fabric geometry, we discussed some, it is warp fabric, it is weft. This is weft and this is warp. And so, how these they are aligned? Aligned in what sense? What angles they make from the axis or the origin? What is their height? What is the length? And all these things. So what is the crimp percentage and everything we discuss about what is the EPI, what is the PI, what is
Yeah.
the yarn to yarn spacing,
Yeah.
and so all these things are different calculated here. So in this there are many results. If I say about the total diameter. Total diameter is a diameter of var plus diameter of weft, and it is equal to h1 plus h2, height of individual fibers. We calculate h1 plus h2. Capital D is equal to small d1 plus d2 is equal to small h1 plus h2. This formula is very, and 1 plus c1 is equal to l1 upon p is yarn spacing, and 1 upon p is n. N is what? EPI.
Inch
1
per
upon
inch.
1 upon p. So getting so 1 plus c1 is equal to l1 upon p2, c1 and p2, and c2 and, so this you have to remember. One is all for warp and two is all for weft kind of fabric. So for all one we discuss about warp things, and for weft we discussed about this. So and the next formula for calculation of
Art will come for ends and weft will come for pick, right?
Weft will come for pick. Certainly, I say pick, but this is warp. This you can say that end is picks. But for individual fibers, if I say, then one or two. Suppose N1 is given, N1 and N2. N1 and N2 is given. So warp EPI and weft calculate.
Okay.
I will be giving you numerical. Hmm. So here, in numericals, I think I have discussed the later section. But in general basis, if I talk about N1, so N1 is ends per inch, means it is for ends, and N2 is picks per inch. So basically, one is for warp, and this is for ends, and two is for weft, and this is for pick.
Okay.
Because in weft only we have picks. Getting.
Yeah.
Okay. Then the next formula says that H1. H1 is what? Crimp amplitude for of warp, and H2 is crimp amplitude of weft. H1 is equal to 4 upon 3 times under root C1 into P2. And H2 H1 is equal to cloth thickness. Cloth thickness is what? H1 plus D1, H2 plus D2. And whichever is greater, we took this. And this is a crimp alteration under root c1 upon n2 plus under root by n1 is 8, 1 upon n1 under root n1 is ne of count of warp and weft count. So this is the type.
What
uh,
is E there? 2.28
e
E.
I say e is a constant. Is a constant here, and this has a definite value. This is given in the question, and this is known as flattening constant. E is a constant value, and it would be given in the question whenever it is asked. But as far as gate is concerned, generally they ask about this part ki, what is cloth thickness, and what is all height and crimp, all these things. They ask about this.
Okay.
And then further, there are two specific types of concepts. This sometimes it is asked both side jammed. This is very important for it. Both side jammed means L1 minus d theta 1 is equal to G theta 2 is jammed means both side jammed matlab both sides are fixed and the yarns are equal types, so the conditions are changed. But for this you have to remember what you have to remember. This is all the derivation that I have discussed, how these things are formed. All the equations will remain same, but for you, for revision, you have to remember that 2 under root 1 minus p by d ka whole square is equal to 1. And this you have to remember for both side jammed, uh,
Okay.
since if it is a square fabric, so 2 under root 1 minus p by d ka whole square is equal to 1 for a square fabric that is both side jammed. If it is not both side jammed, then the equation is 1 minus p by d ka 1 by d ka whole square plus p2 by d ka is equal to 1, because in a square fabric what happens is everything is equal. Everything means p1 is equal to p2, h1 is equal to h2, small d1 is equal to small d2, so all these things are equal, so it is 2 times.